This video is going to talk about solving inequalities by using a graph, by using paper, and by using a table. This first example, what we're going to remember is that when we multiply or divide by a negative number, then we have to switch the inequality. So to solve this one, I'm going to subtract 10 from both sides. So negative 6b is going to be greater than or equal to 30. Now I'm okay so far. I don't have to switch the inequality until I do this next step. When I divide by negative 6, then I have to watch my inequality. And I'm going to move it right away so that I don't forget. So this is b, and that was a negative 6 that it was being divided by, so that would give me negative 5. So b has to be less than or equal to negative 5. So the tricky part about this one is that we have x's on both sides. But if we're careful, we can make sure that it's a positive x so that we don't have to worry about if we have to change the inequality or not. Now, when I look at these two x values, this is 8 and this is 2. 8 is larger and it's already positive, so it would be better to bring the 2 to the other side. So I'm going to add 2 to both sides, 2x to both sides. So now I have 10x plus 1 greater than 51. And if I subtract my 1, 10x is going to be greater than 50, and I'm dividing by a positive number, so x is going to be greater than 5. Now when you look at this one, we have negative 3x and negative 5x on both sides. It would be better to move the 5 to the other side because it will become positive and be the bigger number. So I'm going to add 5 to both sides. So 5x plus a negative 3x will give me 2x plus 5 less than or equal to negative 7. And then I'm going to subtract my 5, and 2x will be less than or equal to negative 12. And when I divide by 2, I'm again dividing by a positive, so my inequality stays the same, and it's x is less than or equal to negative 6. Let's look at some examples that are from a table. So in this example, I'm going to kind of lead you to where it is. So where is f of x equal to g of x? Well, if you look at the table, when the y values are the same, then I know that it's equal. So we would say that they're equal at x equal 5. Now it says compare f of 3. Well, at f of 3 and g of 3, we have 25 for f of x, or f of 3, and 45 for g of 3. So f of 3 is less than g of 3. So there's a less than in here. Now it asks me to go on the other side of my equal sign and look at the x equals 6. So f of 6 is 49, g of 6 is 29. So now f of 6 is bigger than g of 6. So it's greater than. So what intervals of values satisfy the inequality where f of x, 8x plus 1, is greater than negative 2x plus 51, that g of x? Well, that's going to be down here below my 5. Because if I look at 7, 57 is bigger than 35. It's also greater than. So it's going to start where? Well, it starts at 5. Remember, we're just going to put a parenthesis there because it means really close to 5, but not exactly 5. And then it's going to go like that forever, so it would be infinity. And infinities always have a parenthesis. Another example, but this time we're going to look at the graph. It's the same equation, or inequality actually. It's just the graph of it. So now it's asking me to compare f of negative 5 and g of negative 5. Well, negative 5 is right here. So here's g of negative 5, and here is f of negative 5. And it looks like these values up here, this is a positive y value, and this would give me a negative y value. So f of negative 5 is actually going to be less than g of negative 5. Another way to look at it is, we know the higher up on a graph we go, the bigger the numbers. G of x value is on top of or above the f of x value, so it's got to be bigger. All right, now it asks us to do f of 10 and g of 10. Here's 10. Here, this is g of 10. And then over here, I have f of 10. See, it's on the f function. And when I compare those, f of 10 now is higher, so f of 10 is going to be greater than g of 10. So again, it asks us for the values that would make it true. If we think about the intersection, remember we know that at intersections of two graphs, that's where they're the same. And over here, on this side, we have f is greater than g. And over here on this side, we have f is less than g. So we want to go from here over. So it's going to be from 5, but not including 5, to infinity, just like we found in the case before.